Hello, dear students. I am Samir Velankar. I welcome all of you to this another video on array of characters or strings. In the previous video, we saw how to declare array of characters, how to initialize array of characters, what are various ways to input the array of character. There are two ways. You can use scanf with %s modifier, or you can use getS function. We also saw how to print array of characters using printf %s format, and we saw many library functions which can be used on strings like strlen, strcpy, strcmp, and so on. Now in this video we will see what is the relation between character array and pointer. I should say this is not extraordinary, a different topic, because you already know the relation between array and pointer. Pointer basically and arrays are related in such a way that array itself is a constant pointer. Let's see. Here, as an example, I have declared character array. As you see, X is array of characters of size 50. Now, if you draw this X array on paper or assume it in the memory, then X is going to contain 0 to 0 to 49 locations. So indexes will be from 0 to 49, and each location can hold one character. As you know, each location can hold one character, but most importantly, you can see the name of the array is X. Now this name X, the name of the array itself is a pointer, and this pointer X, you know, stores address of the base of the array. If this array starts at location 100, let's say 100 is the place or the address where the array starts. Base address is 100, so obviously the last address will be 149. These are the addresses. Assuming every character consumes only 1 byte, so 100 is the place where first character is stored, 101 is the place where second character is stored, and so on. So indexes obviously are 0, 1, 2, 3. Indexes are from 0 to 49, no doubt. But each location has an address, and assume that the begin address of the array is 100, then X literally stores 100. X is a pointer which stores base address of the array, and we say that X points to the array. So all these features we knew what happened when we learned array and pointers in integer arrays. We saw that if we have int a 5 and we say equal to, let's say in the brace bracket, if you say 10, 20, 30, 40, 50, then we saw in that topic that a is a list of 5 integers storing 10, 20, 30, 40, 50, and obviously the indexes are 0 to 4, but there is some base address of the array, and this base address is stored in array a, pointer a itself is a pointer. Now the name of the array a itself is a pointer, and it points to the base address of the array. Now onwards, you can think of any array, whether it is a character array or array of structures, a double array or float array. Any kind of array is a pointer to the base address of that array. Now let's come to some notations. We are concentrating on the X array, which is array of characters. So you just check few notations here. What if, we write X, only X? What are we going to get? Now you observe in the picture above, what is X storing? X is storing base address of the array. So if you write only X, you are going to get base address of the array. All of you will agree that writing only x is of course same as address of x0, isn't it? Address of x0, because 100, as you see in the picture above, 100 is nothing but address of 0th element of the array. So only x means base address of the array, and base address of the array is nothing but address of x0. Okay, what do you mean by next notation? Asterisk x. Now you know asterisk followed by the pointer means value to which the pointer points. So in the diagram above, x is storing address 100 and value at 100 will be what we are referring to. For instance, value at the 0th element is s, let's say s, character s. I am character at location 0, then asterisk x is going to give us value of x0, and value of x0 is s. So what will be x plus 1? Check the next notation. What is this x plus 1? Now you know that only x is the base address of the array. Now what if you add 1 to it? If you add 1 to the value of x will become 101. Now notice that x will increase by 1 and only 1 because characters consume 1 byte. Just observe the diagram below where we are talking about int array. Suppose for this diagram which I am right now marking, for this diagram, if I write a plus 1, then I may get 202, where a was 200, but now it would be 202, assuming that every integer consumes 2 bytes. But here in this above example, if I say x plus 1, then I am going to get 101. 101 is exactly the address of the next location. 101 is the address of the next location, that is x1. So 101 is in fact one address ahead of the base address, isn't it? So what is x plus 1 going to give us? Address of x1. That's right, address of x1. So in general, what is x plus I going to be? Just check this. What is x plus I going to be? Notice I have not written asterisk before x plus I. X plus I is going to be and xi, address of xi. And what is in general asterisk x plus I going to be? Asterisk x plus I. Now x plus I means address of xi, and asterisk before that is going to mean value of xi. I hope you got used to. I'm just going to clean the slate. You just got used to these notations. Anyway, we had seen these notations quite regularly in the case of array of integers. Same thing has been revised here. Let's come back to this declaration. X is array of 50 locations. Let's say that the base address of the array is 100. X, in fact, then is a pointer to the base address. So x points to the base address. Now, we can write x plus 1, no doubt, somewhere in our program. Then we will get address after the 0. If you write x plus 2, this is the address. X plus 2 is the address. If you write x plus 2, then we are going to get address of the next to next location. I hope you are understanding. In general, if you write x plus I, then what is x plus I going to give us? X plus I is going to give us address of the ith location. Let's say ith location. Some ith location address it will give. Just put asterisk before these notations. Then you are not talking about address. You are talking about value at that location. You will get value at that location, isn't it? Yes. So what will be asterisk x plus I? Asterisk x plus I will be value stored at ith location. But most important thing is that you cannot write a statement x becomes x plus 1. You can't write x should become x plus 1 or x should become x plus I. This is wrong because If x is an array, then remember x is a constant pointer. X will keep pointing at the same location. You just can't tell x, hello x, you were pointing to 100, now you better point somewhere else. Compiler doesn't allow this. Compiler says that I have stored the array at address 100 and x is pointing to that location 100. You cannot change the location of the array. You cannot change the location to where x is pointing. Hence, x is a constant pointer. Whenever you declare an array, then the name of the array is constant pointer. Come again. X is equal to x plus 1 is not allowed, but only x plus 1. If you write, that's allowed. You are only adding 1 to x and finding the next location. X is equal to x plus I is not allowed, but x plus I is allowed. X plus I means you are adding I locations and you are just finding that location. I hope you are. So in this slide, I have made it again clear that x is a constant pointer. You cannot change the value of x. So x equal to x plus 1 is invalid. You can't do this. Remember, array is a constant pointer. So you have noticed how a character array and pointers are also in fact the same. They are related to each other. I hope you will understand and you have understood and you will remember these notations very well. Thank you very much.